Good morning. This may be a short stream because I might get sleepy. I don't know. We'll see. So let's look at where we were. So here's our road network in pink, and we just started putting down buildings in gray. And the buildings are all messed up. And I offline started debugging it and immediately found the bug, and then decided I didn't really feel like working on it. So I have not worked on this, I guess, in a week. And we will fix the bug here on stream. Yeah, good point. There we go. So here's the road network. Just added the buildings in gray. Road network in pink. The gray and green are just showing the squares of the map that reflects this underlying structure of how the procedural gen works. And then here it is in the world, and the buildings are all broken, overlapping each other and stuff, like here. Anyway, so I feel like I'm forgetting something. I don't know what. All right, so let's fix the bug. So there's a thing where we're figuring out along the road where the lots are, the blocks. They're called lots in the code, but they're actually blocks. I want to go through and rename all that to fix that, because a lot should be basically what a building's on. But anyway, so here we go through and we compute the coordinates along that range from E0 to E1, but we initialized this with E1, not E0. So that was the bug. And now you can see the buildings are much more nicely arranged along the rows, and they do not overlap each other. And you can see we have 2 buildings per block most of the time, or some of the time, and 1 building per block. But we still have bugs. This building is not in the right spot, because it intersects that road. So when we draw this in the debug mode, which is in main, just the chunk viewer, let's go ahead and turn on GeoBlend. Enable GeoBlend. Oh, that's not the chunk viewer, it's the road viewer, which is this. Oh, look, we had it before. These are now opaque. And then the buildings are here. So let's change this. So the buildings are transparent so we can see the roads through them, so we can see when they overlap the roads. And they need to be brighter than that. right? So like here, they do not match the roads at all. I think what we'll do is make them a little bit brighter and a little less opaque. So they're similar color, but the pink shows through better. Yeah. Okay, so here's our origin. The white square marks the origin. And we can say, where's one that overlaps strong? This is an intersection, but I can't, it doesn't, there's no pink road through it. So I guess that's not wrong. I'm not clear what this building, like it looks suspicious, but it might not be. No, I've lost the opaque thing here. I'm pretty sure. Yeah, these are drawing solid and these are drawing transparent. Why is that? They're being drawn twice probably from two different blocks, but why? Oh, I know why. That's generate. And we want to say test road network, enable road capture. It's because it's being captured multiple times because we generated the chunks for this test and then we generated the chunks during rendering. So what did we call that? Road capture. So anywhere where we save it to a global is part of the, I think it's just those two. Is it? What data structures do we traverse here? RI list. Oh, road intersections. Yeah. So here's one more. Okay. So now hopefully the double darkening will be fixed. Yeah. Okay. And now we can see that. All right. So a buggy one. All right, so these go up to this road. That's correct. They overlap it a little bit, but that's just because the road is being drawn super thick for debugging reasons. Okay, here's a busted one. So this is road, this is 0, 0. So this is road 0, 0, road edge 0, 0, vertical. So then we say road edge. Compute road edge 0, 0, vertical. So then the issue is where the buildings are. So we want to find code to make the buildings. which is here. Okay, so the first building we build, Q0, P0, well, it's actually Q0, Q1 is the coordinate, I think. 0, P1. Okay, so this went through this path, which claimed it didn't have a facing road. So what is N, and what is RE rec of N? Facing road distance of 0. Distance from core 241. This doesn't sound like the right one. E0 to E1. Oh, it's because that's the end distance. Could this be 121 to 241? I guess it could be. So why didn't we have a facing road dist? Okay, I need to look at it again. Well, right. No. Why are we calling this multiple? Oh. I guess we're generating. Why do we keep generating this? How many times do we need to generate it? What? Oh, yeah. Okay. So let's change this breakpoint to only fire capture during that startup period. So we should only hit it once. Twice? Twice. Twice, because the edge is seen by two different chunks. Okay, so this is this one right here. Okay, so this is 256, so it's staying from 121 to 241. There is a road. The road is on the right side of the chunk. This one doesn't have a road. Didn't extend all the way up. Interesting. Okay. You said this is true, so we found one. We could make a connection at -13, but I think we're going to use a tangent connection here. No. No. Wait, what? -13 is on the left side. Oh, right, then there's this logic. Okay. Right, so now we get side distance of 0 is 28 on the right. Side distance of 1 is 38, which is also on the right. pick the side disk transition to be 0. I think that might be why. So it has to flip from connecting does anyone want me to explain what's going on? Or shall I just stare at the code and think? So where do we make use of side disk transition? Here. J-1 equals side disk transition. Then we force that to 0. That's just Z again. I think I don't actually want to allow, in the same way that I only go up to lots minus 3, I think this wants to go 1. This kind of wants to go 1 as well. So we don't hit this case at all. But probably we need to handle this case anyway. So we should handle this case first before I make that change. Okay, we say so we've built one entry. But this is the one that corresponds. So this is the one that should generate the road. So why does that road get generated? So that's the west road. Which is road 2. I don't know what's the... Okay, so this is the one on the left. So we want chunk 0, 0. So we run again. Now we break. Now we're being called from... Yeah, this can be an edge of 2. So it should be that edge that we just looked at. Origin 0, 0, vertical 1, yes. And the first red edge crossing, dist 121, facing road dist 28, facing road dist 0. So this is the supposed to be a gap in the road, but it's generating a road. It seems like. which is here. Or is it this? Let's see, we're vertical, so we're making an edge that's vertical. This is a horizontal road. Okay. We're vertical. This is making a road that is vertical. Wait, why are these two using dist from corner? What? Oh, because one gets overridden? No. What? What is this logic? Dist from corner. So this is another horizontal edge. Well, why do we make the horizontal edges twice? Am I sure this one is horizontal? Yeah. It is. I don't know why we make them twice. I'm sure I knew once upon a time, but I didn't comment it. Okay, so here's where we make the vertical edge. And we use side, which is facing row dist, and if side is not 0. Okay. Why do we go 0 to e numrect minus 1 and not 1 to... I suspect this might need to go from 1 to... Alright, let's see if we change side to be j plus 1, if that just fixes everything. This road is up against that. This road is between these. This road is against that. No roads. We're looking for, do roads ever intersect buildings? Don't sure what that... Oh, the reason we draw the clipped roads twice is for either side, I think. Yeah, this does look like it fixed that thing. Here's a place where we generated 3 buildings in the lot and extended them too far in that direction. So how does that work? How do we decide how far to draw them this way? I think we just do it arbitrarily on the assumption that the roads would never extend out far enough. But then mistakenly we generated this sticking in too far, I think. I think that's what's going on there. I think you mean that's old. So what was I saying? That was the building thickness. Where do we make the buildings? Make, that's make road edge. Okay. Default size, it looks like. Yeah, we're using min lot size to mean both block size and building size, I think, incorrectly because of that ambiguous name. So I think a lot of this logic is kind of wrong. Although I think the original intent was that this would be a building lot, but then when I was using it with the roads, I started, yeah, because the corner has to be 2 by 2 buildings, so that's why that's what it is. But then when we split it into multiple lots, which should be blocks. Okay, let's start with the renaming here. Yeah, here we go 1 to blocks, and in that other place we went 0 to blocks -1. So I think I'm just not being very consistent about that. Okay, then lot size. See, there we go, yawning. Lot size becomes block size. No, don't do that. There we go. I guess we can do that to avoid that. Oops, I skipped one. What happened to the one I skipped? I just happened to land on it. Okay, builds. So I probably got them all. Okay, so now when we're computing the block size, so we compute the number of roads that are crossing, which is also the number of blocks, or 1 less than the number of blocks. We divide up the whole size by blocks. We set a minimum block size of 120, which is just arbitrary. This doesn't need to be limited. This can be arbitrary. Well, kind of. If it's a block that has a facing road, it can be arbitrary. If it's a block without a facing road, then the size depends, which means I should do the facing road decision first. But the facing road decision depends on the number of blocks. Did I never switch this into generate pieces? I may never have switched this to use generate pieces. But what, so I was going to say is generate pieces can change the number of count. So theoretically, we should pick where the facings are, where the split is. As long as you have a facing road, you can have more than an RHI size block. But if you have no facing, you can only be a 2 building wide block. So you need to know whether you have a facing road before doing this. But the size of the blocks would be determined by generate pieces. Needs to know the number of blocks, but can change the number of blocks. And we can't decide the transition until we know the number of blocks. Ugh, what a mess. So we need a fallback solution. Okay, so we need to compute the number of blocks and then use generate pieces. Which is because that's why we wrote it. The whole point of generate pieces is to solve this problem. Block size, num blocks. The total is sum, which is what, D. I lost my autocomplete. The min is min lot size times 2. And the max is arbitrary. And then that becomes num blocks. This is more code trying to keep that all in range. Okay. So this code all can live first. This is all fine. It's only when we do side meet that we compute where it happens. Right here. Oh, it's not num blocks, it's blocks. Probably change that to num blocks just to be clear. Okay, so all of this code up to where we compute blocks, to use blocks, can be moved up. To before this logic. Make sure that builds. Nope, this one can't. This code is dead. And there's a lot of dependence on blocks less than 3. There's blocks that's less than 3 here as well. I think this was a thing we had to add because of this logic, so it broke. So if useIdist is true, that's redundant now. And then useIdist never changes throughout any of this code. So this is redundant. I wonder if this should be 1 comma blocks minus 2. The whole thing about there only being 3 blocks. I think we're hitting this case a lot. I'm already tired. How long have I been streaming? Only a half an hour. So unpredictable. um, I mean, I guess we can test whether the generate pieces thing even works. Yeah, I need to draw those roads correctly. That's annoying. But yeah, it seems to be like here we got a short and a long one for once. This is a problem because this can't connect. How do we guarantee connectivity? How do we guarantee connectivity? I guess we don't. Okay, so block size now is we fixed. And so we were worried about the min lot size for the default size thing. Default size. So this is a default size for the building on this edge. So this is just a hack that we did so that we could put down buildings of some size. Okay, I see. Which is why all these buildings are very homogeneous, because they're all the same depth. Although these are not the same depth. It's very odd. Why are these not the same depth? I'm feeling like the road scale is still wrong, that I actually need to double the road network scale. I guess I can make the building smaller. There was an if for that. Why is there a building from 31 to... That's from an RCH, which is what, a road chunk. There's just some logic where something got too small and overflowed or something. Oh, well, oh, it's different make building. It's make clipped building. Came from an edge. Which means it came from make building. But make building has an assert. What? B of P is x0, B of Q is x1. P, x0, Q, x1. Is there a path that doesn't use make building? It's part of road edge. E-building. Building calls make building. E-building calls make building. Do we have more than 8? Aha, right, because we bumped up the count. So there's no range checking on that. Okay, so now why are we getting more than 8 buildings in some places? Oh, well, here you go. How big are these buildings now? Yeah, these buildings are a little too small. Don't have room for a central column. Okay, so buildings can't be that small. Can't really see how big that is. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, it probably is 40. Well, I was just wondering if it was actually smaller than 40 somehow. Oh, it probably is because we pull it back a little bit too. So maybe the smallest we can be, say, is 70. So let's find our smallest building now. I guess that's viable. It's a little small. Yeah, maybe that's too small still, which means if the buildings have to be larger, that's a reason to make the road chunks bigger. Looks like in real buildings, you could have 20 to 30% of the building taken up by stairs and elevator shafts. So if we look at this, I mean, we don't have to be exact, but just getting a sense of it. So 1, 2, 3. Oh, well, I can just look at the code and figure out how big it is. Stairs. Make stairs. So currently we're generating our stairs at, oh, well, we can just look at the whole thing. Elevator shaft goes from x minus 20, goes from that to that, and y minus 8 dot y plus 8. area equals 28 times 16. $450 voxels. And if that is 20%, that would be 2240 voxels area, which could be square root. Where's the square root? 48 by 48 voxels. Okay, so yeah, it looks like it's taking up a huge slot if you go down to 50, but it's not unreasonable in the real world, it looks like. This one is way too small, though. Yeah. This is a building that's generally below the min size. Oh, no, because I go up to plus 20. Plus exteriors. I go to x minus 20. So if we offset all this a little bit, add 6 to everything. Wait, add 6. Add 6. So that becomes minus 0. That becomes 14. Becomes minus 0. Becomes minus 14. Okay. So now it'll be centered. Yeah, that's a super tiny building. That's brokenly small. Why is it so small? I don't know. Can we figure out which building that is? Looking for that pattern. 3 stripes down the middle. That's this one, I think. Like this. Nope. Why do I keep getting turned? Okay. Yeah, that looks right. Okay, and then which one was it? Bottom right? This one right here. So that's corner 0, 0. It's just because we're pulling it in, but I want to look at what the code actually is doing. So it's 0, 0. So it's corner 0, 0. Road. We just do this totally random thing, and if it's the minimum, that's totally wrong. Yeah. these numbers aren't even right when it gets this small. So this actually wants to use generate pieces. So we want to split it into two pieces that meet that constraint. And if that fails for some reason, if it turns it into only one piece, then we just split it in half. And then we do the same logic for y. Now, we're not contracting it from the sides at all. Is make building contracting it? Nobody is contracting it. Here we contract it. Should run it 4 times. No, incorrect. Funny, but incorrect. Nice. That was the y value. That looks fine. That's x. That is xy0. Okay, I just the math is wrong. Like the way I'm computing it is wrong, probably. Yes. Why did that end up only 10 wide? Oh, because I used X. I got my cut and paste failed. Okay. So hopefully all the buildings are reasonably sized. Okay, and so then we do a biome thing where you could have buildings this small in some biomes, but not in other biomes. Do all these need to be the same depth? I think they do. In a single block, I think they do. Because that makes it easier to match the other block to them if they're is that a valid phasing? Are we not contracting our blocks by the road size? We're not contracting our blocks by the road size. We need to do that. Maddening. So many little subtle things. Okay, so the lots have to get contracted by the road size. The buildings, we're calling them buildings, but they're actually lots. All right. Go ahead and ask me questions. If you have questions, I'm going to eat. Let's make Control Z. lost by default. By the way, last week I did a programming stream on WooCache where I wrote from a blank file in about 90 minutes. I wrote 350 lines of a twin stick shooter. And that's not available as an archive directly because he wants to edit it, so it'll be available in maybe a month or so. So you can see me code this in about 90 minutes. Not a lot of code. And yeah, I didn't announce it in advance because I was just too busy. I didn't announce it in advance because I forgot to. And then when I was before the stream, I didn't mention it on socials just because I was too busy trying to get everything working, technical issues. I'm on my lunch break. I didn't stream that much last week anyway. Only streamed Monday, I think. Plus the Wukash stream. Any questions about anything? Let's see. It went well. I just showed what I made. I can do it again. Spoilers. The player is invulnerable in the sense that the player resets to a random location when it gets hit. Yeah, so I made this in about 90 minutes on stream from an empty file. And it'll be on YouTube in a while, a month or so. Well, I guess me saying that is flexing, but doing it on stream to show it being done is hopefully inspiring rather than flexing. Which was the impression I got from the chat, although I wasn't watching it very much since I was trying to get it done, which was hard. Yeah, don't worry if you're joking and I take it literally. Streamer brain. It's just easier to answer everything as if it is true rather than, even if I think it's a joke, it's easier to just answer it as if it's true. I feel like I'm too tired to think this through. I've been struggling. But we'll give it one more try after I clean up my lunch. And if we can't get there, I think what I'll do is I'll start commenting the code, since I should be able to do that brainlessly. All right, I'll be right back. So there are two competing forces for why the code isn't getting commented. One, which we've talked about in a previous stream, is just that me explaining stuff on stream tends to substitute for writing comments in a bad way. Like, because I'm saying it out loud, I don't type it. But then the other force here is that this is proc-gen code that's sort of disposable. Like, I don't really know what's going to work and what's not going to work. A lot of throwaway. Adding to is not, something you can really comment very well. But at this point, there's enough code, and I am having, like, what is this code doing? Experience. So it's probably worth commenting it. But first, we'll see if we can just get some better generation stuff going. All right, so I wanted to try a smaller lot size to make sure that stuff would work. Oh, because I wanted to see, should I make a larger road chunk size? And I guess the answer is no, it's okay at this size. Why did these only generate 2? That doesn't look right. Let's find another place where it's only... That's happening a lot on... If there's no facing, it's correct to only generate 2, and then they need to actually get expanded to fill. If that, and there's no facing, but if there is a facing road like here, then that's wrong. All right, so let's find the origin and find the easiest one. Hey, look, this has no facing road. Oh, right, and that was that whole issue we were talking about. Okay, this one has a facing road. So the vertical, 0, 0 vertical, it's not generating the right number of buildings. So let's look at that. Okay, let's check that it is doing what we think it's doing. So the first block, we generate buildings. Here. So the first block that we generate, 2 buildings. And what's facing? There is a facing. Why do we clamp it to 2? Oh, no, it's max. It's at least 2. This one gets clamped to 2. Okay. So we checked that it was in fact doing what we thought it was doing. So now we can actually step through watching it do it. Oh. Oh, yeah. That explains the pattern. This is not equal to 0. Okay, but we're still getting gaps. Ah, but the gap is when there's no facing road. Oh, but here's another broken one. Okay, that's correct. Not sure why it made such a long gap. Probably should check that. Two roads, two roads. We're looking for a gap when there's like that, but there were bigger ones. Yeah. This is the biggest one right here. So that is at 1112 horizontal second region. 1, 2 horizontal second region. One, two, horizontal. Second region. Number of links is 4. Because we just have this weird arbitrary function here. Okay, but max lot size makes it want to be at least 5. Make the third building 207. Oh, and then we clamp it to the max. So we get here with excess, and we try to redistribute it, but there's not enough to redistribute it to. So we make them all the max size, and that still leaves the gap of whatever the excess was. Yeah, we get here, and excess is still 127. Which actually, it seems to me to imply that this excess logic doesn't work. Oh, because they're already at max. Right. Okay. So this int min equals e1 minus e0 over max lot size. That rounds down. All right, so that should address that one. Yeah, so now we get lots of buildings everywhere, and it's just these. Okay, and those, we know what that is. That is exactly the thing I was originally talking about when I reordered these. The place that it's being split has no facing road. And that the one that has no facing road needs to have smaller block sizes. So what we want to do, so we moved all this logic up early. So what we want to do we can kill this code off because I'm comfortable with the generate pieces logic now. So we could do a tentative version of this before we run it. Okay, yeah. So we can say, this is really a case where I wish I did have declare anywhere. So then if blocks does not equal old blocks, then we've changed how many blocks we had, and any logic that was relying on how many blocks we had has to get run again. Now, one thing this might do is disable use side dist. Fun fact that I'm copying logic that says this logic is broken. So this case can happen if blocks is less than 3, but it could have happened before if blocks is less than 3. So could that break? No, because blocks can only decrease. It can't increase. And so if this triggered up here, now side dist is false and we don't run any of this code, but that's consistent. Okay, so if use side dist gets turned to false, that actually changes generate pieces logic. Okay, so so if bang side dist meet, if there's a place where the side dist doesn't meet, then we have to have. Oh, this is so complicated. If we don't have a side dist, then these have to be max 2. Because if you don't have a side dist, you're just a series of you have blocks running the across the edge. If you do have a side dist, if side dist meet, if the side dists meet, then we can do the full thing. If side dists don't meet, then there's one block that can't be too large. So we say D minus equals min lot size times 2. Well, I guess we do the average. And then we'll add it back in on the opposite side. And then we say blocks minus 1, blocks plus 1. We only do this if blocks is greater than 1. Let's put the 1 plus at the front to make it more obvious. So what we're doing is we're making one block be effectively this size. Namely, this block is min lot size plus max lot size. And we need to swap that to be where the side transition is. So once we've computed the side transition, we want to swap that one with a random one. But they're all random. They're all equally random. So Because right here, we fill that one in. Maybe? It's probably off by 1, but maybe that's enough. So now we don't have a big gap. So anywhere where there's no facing road, there's only ever 2 buildings. But now anywhere where there's no facing road, those 2 buildings shouldn't have a huge gap anymore. Oh, here's a gap that, oh, that's just because 8 buildings isn't enough. I should just have a pound of time for that. Okay, and then let's make max lot size a lot larger to allow more variance and see what that does. Makes these corners crazy sized. There's some variation here. Not as much variation as I'd expect. I guess that's because I'm generating numBuild in a not smart way. The initial guess here. I should just have these. I always get these. I always get confused about these. We have to at least is max, right? Yeah, okay. Okay. So now we have a totally different way of deciding the number of buildings. And that choice forced them all to be small. This choice allowed a variation. So we want to avoid choosing the large. Like having that be linear is wrong. Choosing small allows a lot of variation. Choosing large allows minimum variation. So we want this to be biased towards min. What is it called? RRM. Let's just use getRand. So if 2 bits are set, if either of 2 bits are set, then we'll use some other thing. And that other thing will be the average of the two. So that only a quarter of the time will we go above the average. Which is still being hit here, I think. Like, okay, there's variation in the sizes. But also that road placement is wrong. Like, this needs to leave room for another thing. We need to somehow encode that fact. Ooh. Do we want to force a road on that side? I don't think we do. But we do need to force a minimum. To avoid this kind of thing. Oh, and that's an interesting one. This lot is way too tiny. Yeah, a whole host of problems when we've set these to small. But okay, we did fix that thing. And yeah, it doesn't really count as a bullet item because we're still so in progress on this stuff. So what's a better way to do this distribution from low to high? Roll 2 dice? I don't think we want, I think we want the bias to be towards small though. Maybe this is good enough. It's only for the edges. I mean, we'll have a similar problem once we start populating these. Yeah. I'm thinking again about these all being the same depth. I'm not sure. certainly these don't have to, since this faces that way and this faces that way, these don't actually have to match these sides. I think we're going to comment. We're going to comment the code. Yep, hey, look, I had already done that there. So yeah, while I'm commenting, if anybody has any questions, feel free. D0 is 11 bits? Why did we end up at 11 bits, not 10 bits? Oh, I think, yeah, I just added some headroom just in case. So this is 11 bits, that goes up to 26, so that leaves 2 bits. So there's 2 bits free in this. Do you implement your own getrand? Yeah. I used PCG, actually, I think. Oh, it might just be local. Yeah. Yeah, I used PCG. I use PCG just because it's fast, and has 32-bit version. Like a lot of modern random number generators don't have a 32-bit version, and since VC6 is only 32-bit, I have to make it run in 32-bit. So PCG seemed like kind of the best for 32-bit. The 32-bit is this hacky thing that uses some of the bits in 2 different ways, but which slightly breaks the normal PCG guarantees, but it's fine for our purposes. Like it could use a much weaker thing and it would probably be fine. Okay, so comments. All right, so all the puts don't really need comments. Pack doesn't need comments. Make elevation have mixed stairs. Create building is a total hack, so it doesn't need to be commented. Those are self-commenting. Well, not just the shape, it's the corner coordinates of lot containing building. I do not have a take on the deal of this slot. I mean, I guess I have a take. I just decided not to share it. Shall I share my take on DLFs? Because I'm an anti-AI person, and this is one place where I kind of have like a subtle thing, and I decided not to share it because I didn't want to say anything that could even be at all pro AI. So back before we started calling it slop, I did play with AI. I played with Stable Diffusion a lot, and I used ChatGPT 3 or whatever it was. I haven't used AI now in like, a year or two or whatever. Because I just think it's bad and shouldn't be supported in any way. But so if you know about Poser, this is a program that's a bit like Poser, called DAZ Studio. That is a program for creating 3D scenes using pre-made characters and pre-made other stuff. And they use all the stuff is PBR, physically based rendering. So they have PBR textures and everything on all the characters. And they came out with Genesis 9, which is their newest character model family, because they each character model base then has morphs and textures to let you make other characters with it. So they came out with Genesis 9 a couple years ago. And a thing that you'll find in the forums, but it's unclear what anyone uses this for professionally. They claim like that movies like use them for animatics and stuff like that, which seems very unlikely to me. But in terms of professional use, like the main one that I see in the forums is people using it to make book covers. And obviously they like look kind of crappy 3D models when you see the art out of this goofy context. Like even here, this one doesn't look that photoreal. I mean, it looks decent, but the thing that I was getting at is that there's something here that even just Stable Diffusion 1.5 many years ago was hitting a level of photorealism that they're not hitting. And the thing you'll see in the forums that people talk about, for example, is that they're like, there's no look good button. Like you have to still have skill to make a good shot, to make a good rendering. And these people are wrong in so far as we should end up in a situation where PBR means stuff looks photoreal no matter how badly you light it. It should look like how the real thing would look under that bad lighting. No, I've never had a problem with it crashing uh, on projects BC6. Um, so if PBR works and you have correct PBR textures and a shader that works, and like when you dive into the details of it, it's like, yeah, it's not clear that we really have this yet. But if in theory you had all that stuff correct, um, the uh, the renderer that this uses, it's an offline renderer, right? It's not a real-time renderer. It's an offline renderer called iRay. It's something NVIDIA actually makes that is a PBR path tracing renderer. So like subsurface scattering is implemented by bouncing photons under the skin, right? So it's like super realistic. Like if you backlight an ear, it will glow. um, but so there's no make it look good button. That's true. You still need to compose your shots and put in good lighting if you want a good looking image. But you should get a realistic looking image, a crappy of a crappy scene, and you don't. You get Uncanny Valley. And they made their newest character a couple years ago, and they put in a new shader, and it's barely changed the degree to which it looks Uncanny Valley. It looks like a 3D rendering. Um, like that looks close, but most of the time when you try it, you will find, yeah, it's not meant for games. Like they do have interactive licenses or whatever, but uh, it's meant for offline rendering. Like this just doesn't quite. I mean, part of it's the hair, part of it is the hair, but it's just not quite right. Um, and one problem that you have is in the marketplace, you get lots of other people making models and stuff, and they don't understand how to make PBR textures correctly. They end up putting lighting into the diffuse texture and stuff like that. Um, like they know better, but like way too many people are still like taking a random photographic image and running some program on it that tries to generate, that uses the color data to generate a height field, to generate a bump map, which is just wrong. Um, so anyway, the upshot of all this is so one thing that people may be doing is they take the output from this and then feed it through a shader to just through an AI thing just to get it to look photoreal, to remove the uncanny valley. And I I don't wouldn't blame them for that in the abstract of like it's frustrating that we have this tooling that is supposed to be able to get to photorealism and it doesn't quite look like it. Um, oh, I said what I said. So there is a tiny thing here, which is that yeah, like I can see why people might say, hey, AI can get us to photoreal in a way that 3D rendering is not getting us there. This is offline 3D rendering, much less real-time 3D rendering. So I can see why you could go down that path. That's my hot take, is that everyone's just flat out rejecting it without even making that argument. So yes, there is a yassifying and all that. So there is an argument, I think, that it would be nice to get to photorealism proper, and it's a surprising fact that the AI stuff gets way closer to photorealism than the PBR stuff does. But it does. It seems like even on offline. I mean, I only know about devs. I don't know what actual movies are doing, how they're getting good-looking virtual characters in movies. Um, but in what terms of what's accessible to consumers, that's where we are. So I can, again, I'm anti AI. I don't actually want to see this happen, but there is like, you could see why somebody might think, oh, this looks better, in a sense of um, if you were the art director on the project, you could be someone who says, oh, if you turn on this AI thing, it looks better. Like, I'm comfortable with that. It like looks more photoreal. there is a space for that. That's not how it seems like the DLS S5 stuff like was introduced. Like they claimed that devs were supporting them, but it was actually publishers supporting it or whatever. Um, so there's like it's interesting when you see a subtlety like that gets ignored. Like that happens a lot in like political discussions too. There's like the side that you're on piles on against something, and you look at it and go like, there's something a little subtler than that going on. You're dismissing this in an incorrect way, but it's just not worth having the argument about it, even though it's making your position worse because it's using a bad argument that can be contradicted. Yeah, the de-aging thing. There's the similar thing with the when they put Luke Skywalker in Mandalorian, and then the corridor crew ran a deep fake and got it looking way better. I mean, it was corridor crew. Like I don't know that it was how legit that all is, but probably it was legit. So anyway, yeah. So I think the DLSS 5 it's terrible. It's so they're they were just shooting themselves in the feet with their weird way of describing it. Like the it's clearly just a filter, but they're saying it's not a filter because they're trying to say it's not a Instagram filter. But it's like they say, it takes as input the color and the motion vectors. And if you set aside the motion vectors, which you can, like it's basically just running through a generative AI filter, and you can tell from looking at it. Yeah, the upscaling is a really interesting case. Used to be called super scaling, super resolution. That was the old term we had for it. The idea that, like, if you wanted to scale up by a factor of four, no, super sampling is something different. If you wanted to scale up by like a factor of four, like, what detail should you be adding there? And this was a problem that we were thinking about pre the deep learning stuff. And it was like, well, clearly you want to add this fake detail that corresponds to what's there. And it was like very unclear how would you do that. And uh, and of course, then deep learning came along, and it's like, oh, here's how you do it. And there have been these, there in fact factor of four in each direction super samplers, uh, uh, neural net things that I was using when I was using Stable Diffusion. There were a couple different ones. It's unclear where they were coming from. They clearly were trained. They were all the exact same size networks, so I don't know. Uh, Remacry was one of them, and there was like Universal Superscaler or something, and they were clearly trying to do this, and they did terrible jobs at it. Um, but this was a couple years ago. I don't know what the best ones now are. I mean, the other thing is like obviously, um, if what you're doing is generative AI, then you can also just upscale and then run the generative AI on the upscaled image to fill in the details. Um, and that way you have a prompt that's actually guiding what's supposed to be there, as opposed to like just the blind super resolution that's just trying to look at the data that's there and infer. Right, like the early ones of this were basically like before deep learning, we're like, well, we can kind of reconstruct an edge. You can say, oh, we can see there's an edge between two colors here. So when we super resolution it, we can try to reconstruct that edge in the right spot because we could see how it was anti-aliased and kind of reconstruct it. But you can't really fill in real detail. Whereas the AI-based stuff can potentially go like, oh, this is a fake, this is an eye, and I know that the eye curvature is like this, and you know, do some magic there. And so like, there's definitely an interesting place for AI super resolution. Um, but yeah, like I'm definitely one of those fake pixels people, right? Like the whole fake frames argument with the DLSS, where the fake frames are just motion smoothing that we've had on TVs for a long time, um, and uh, that's uh, I I assume the fake frames were being generated from the frame before and the frame after, so that disocclusion wasn't a problem. Um, but anyway, so I'm like, I don't even like TAA, and so like, I'm firmly of the like, use super sampling to get a higher quality image, as opposed to generate a lower quality image and try to fake a higher resolution image. Yeah, I'm using the language of Gamers Nexus, I think, or just the community. Yeah, the frame gen stuff. Yeah, of course it's unrelated, but it's related in the sense that we're generating data that's not already there. We're generating data that the game didn't generate. That's the whole point. So that's common to both upscaling and frame upscaling effectively. All this AI hype talk, I just want to dig a hole, live in it for a couple decades. Yeah, the intrusion of AI on programming is, I'm in a happy place of not being programming professionally, so I can just ignore it. I can just do what I want programming wise. I don't have a boss who wants me to use AI, and I don't have to deal with coworkers who are using AI, even if I don't. Even, I could imagine I having a boss who isn't pushing AI, but my coworkers are using it. And I don't have to deal with that either. We need to go through and do intersections. Do you ever feel like, hey, I should try out a new programming language, or have you evaluated and rejected them already? Neither. I am a person who does not upgrade. Like, I've invested time in a thing, and switching to a new thing will require a new time investment. And so I usually assume it's not worth it. Certainly for programming language, because I prefer VC6, I basically stuck with C, with C89, since I would just have to change otherwise. Okay, so what do we have here? Is there any situation where you'd move away from VC6? I mean, if there were a compelling language, certainly when I have to move off Windows 7, we will have to reevaluate. Can I even install it? As I've said before, I do use, when at work, I was using a more modern Visual Studio because I had to build the C++ and everything. I wonder why I'm doing this. Seems like I should oh, I see. No, that's a min on the. I just want that. Do some language features intrigue you though? Yeah, I mean, I in 2006 ish, I was rating my own language. Um, like the Jai syntax came from that language. The syntax for variable declaration slash initialization slash assignment. Um, you know this. Uh, um, and that language was what were the features of that language? So that language was strongly typed, but with type inference, like ML style type inference, basically, and much more aggressive than like the C++ auto. Um, what else did it have? Defer, which is uh, a lot of the new languages have this now. The run when a destructor would run, basically, so that you don't have to write dummy C++ classes that to trigger the destructor. You just say run this at end of scope. I don't know what's good and bad. Um, Trying to think if there were any other features in that language that were important. Oh, it had a weird type system, even though it was strong typed. Had a pretty weird type system where you could union anything because it was under the hood, had a dynamic type style encoding of types. So you could union together any two things, and it had the tag information to effectively a tagged union automatically. Um, and that was all interesting, but I could never figure out. I was considering garbage collection for it because its goal was not to make a video game engine, but its goal was for writing tools, where maybe not having to worry about memory management would have been nice. But I had never decided on that. This was before Rust, or before I'd heard of Rust at least, so I didn't even know about the idea of like a bar checker. I don't know what goes defer does, but yeah, end of current scope is what it was. Um, I think it. I think I had an insane syntax for it too. I think it was that meant defer. So it would be like, not that you would literally do this, but you know, I think that was my syntax. Oh yeah, that's terrible. Um, but I might have changed it to just be defer. I think Lisp actually has a defer, so it's not like this is a new thing. Maybe not. Yeah, the with statement is an interesting way of scoping it. But anyway, so of all of that stuff that I was just saying, defer is nice, but it is non-linear code execution that might be bad actually in terms of the potential for bugs. Um, the the type inference was great, except I don't think it's viable. So ML type inference is like um, very formalized, rigid, consistent, guaranteed to work, forces all sorts of insanity, like you can't coerce between floats and ints. Um, and you have to not just that you can't coerce between floats and ints, you can't do operator overloading. You can't have time. You need a separate multiply for floats and ints because you have to be able to infer from the multiply operator that the data on both sides are ints or floats. So I was trying to write one that was more ambiguous about that stuff. That was like, um, it can defer knowing the for sure what the types are and propagate that information around and eventually figures out what the types are. And as long as it eventually figures that out, then the program is valid. Um, but what I ran into was I really wanted that if you said foo.bar, then we could infer that foo must be a type that has a dot bar. And the problem with that is that, if there's two structs, it makes sense. There's two things, and you see x.bar, then you have to compile error. Well, you might have, if you later see x.baz, then you can figure it out. But if you only see x.bar, you have to say, I can't compile this function. I don't know what type x is. And the problem that I had was that if you imagine you're using like includes, you could have these types and only include this one. And so then this compiles. But as soon as you include this one as well, then it doesn't compile. And that just seemed busted to me, that like that the code that adding a new include, it would be an import, but that adding a new include could cause this to switch from compiling to not compiling. So now you could just remove that dependency. You could say, well, if it's a struct thing, you don't do that. And then I think it was tractable. The idea being that, like, if all you did inside was math, it might be ambiguous whether it's int or float, and then it would complain, and you would have to declare something somewhere in there. You would have to say what's an int or a float. Yeah, exactly. It's just that you could break existing code, right? You like change a header file, quote unquote, a header file, and a bunch of other files suddenly break. Like that's would just be a terrible experience. Um, but if you don't do that foo.bar thing, it meant you basically had to declare all your structs always, because that's the only info you get about a struct. Like you either are assigning it, like if it's being assigned from another struct or a function that returns a struct, then you could infer what struct it was. But if those things weren't declaring their types, then your type inference had a lot of trouble getting anywhere. And so it seemed really useful to do that. And not doing that made it just seem like, maybe this kind of inference isn't worth it. And I actually remember, the biggest thing though that I was like, okay, so if we turn off all that, even then, the problem that I had was that there was no rigorous definition for what the type inference was. The type inference rule was what my compiler implemented. And having that be that made it not a very viable language to share with anyone, because it made it impossible to write another compiler. I mean, Jai is deeply down that path anyway, though, so maybe. Um, Do we use W2 and H2 anywhere? Nope. Yeah, I saw he opened up the patent. Yeah, I've been meaning to write a little paper about that. That's something that Fabian and I worked on 10 years ago or something, um, and concluded it wasn't fast enough. We weren't doing what Slug does, we were doing something faster. And we decided it wasn't fast enough and dropped it. But, you know, GPUs have gotten faster, so maybe it's more viable. I don't know, 10 years is a guesstimate. So yeah, not something I would work on, but I should write up what we figured out. Um, what we saw was that if you displayed a full page of small text, a full screen of smallish text, it was taking, I think, 10% of the GPU that I had, the 10% of the available frame time at 60 frames per second. And that meant on mobile, it would be a lot worse. And so we're just like, that's you're spending too much time on just rendering text. Better to cache the text into um, uh, FCFs or something. Like you're just doing so much work to recompute the same thing over and over. Um, and also, unfortunately, the quality we had was a little bad for animation, but the touchstone for this was a thing that Will Dobby did. Will Dobby text rendering. Yeah, 2016, so it was exactly 10 years ago. So we were starting with his method and trying to make it bulletproof because his method is not bulletproof. If you watch the demo and zoom in really far, you get glitches. I don't remember where the glitches were, but we saw glitches. And we know why. Like we figured it all out and figured out how to make it bulletproof, but our version of this we felt like was too slow. I can't find any of the glitches, but there are glitches when you zoom in. I think it's just specific characters. It probably doesn't matter where they are on the page, but maybe it does. I think it was only if you zoomed in really far, but he does the, well, okay, nobody does the correct winding rules. That's something I need to talk about in that paper. I mean, it's the same, it's what STB TrueType does as well. There's the whole write-up about how STB TrueType, I changed the rasterizer, and the new rasterizer uses a different fill rule. It's just not worth, it's not worth doing the real one because you can't integrate the real one, but you can integrate a fake one. I can't find the glitches now. I don't know why I'm doing that off screen. That's silly. Here, there's a row of dots here. Don't know if that's coming through at all on the stream. Almost as if there's an invisible edge here, but there isn't. I don't remember if that's the kind of artifact we were seeing or if this is something else. Yeah, I mean, the more I zoom in, the more prominent it becomes, but it's happening infrequently, like at this scale. Like if you dragged it around, it is happening, but I don't see any, but it is happening. Just the more you zoom in, the more frequent it is, but and obviously that's an extreme case. Like I said, we were just trying to figure out how to bulletproof it because it does mean that like at this scale, maybe one pixel is wrong, maybe not, but like some of the time. What causes it? That's why I have to write the article. It's very, it involves all the details of how this thing works. So like, here's the thing. Like, what you could do is at every pixel is compute the full winding against the full shape. Traverse the entire shape, compute the full winding, and you'll get the correct results, and the pixel will be correct. So the trick is to only test against some of the curves, some of the edges. And Slug does that by dicing into rows, sections, and computing when you compute the winding rule, you scan from your pixel like left, say, along X, and just look at all the edges along there. And so Slug splits it, into horizontal bands, and now you test against all of the things in your horizontal band, and that will produce the exact same results because you're looking at all the edges. But what Dobby tries to do is put a grid on and chop it down into 2D and only look at edges that affect the grid, that fall within the grid. And the problem is that there's some subtlety to how to do that and make it work, and he didn't. I mean, he did, but is broken. The method he uses to do it has this hole that causes this artifact that we're seeing here, and that can cause bigger artifacts in other places. I just don't know where they are. I guess I should check if I zoom into that same level on other shapes. Do we see the exact same thing, or see where would it be? It would be it has to do with where the grid is, and so because the grid isn't displayed, it's hard to guess where the artifacts are. Was it the A that I was seeing it on, or was it a U? It was a U. Yeah. Okay. So this one is doing it on this side. Anyway, yeah, so it's hard to do the grid split, but the grid split is what you need to do to really reduce the number of edges you have to compare against, because Slug still compares against a lot of edges, and but at the time we felt it's even slower than what we were doing, so probably unacceptable. I mean, we did try it, but mathematically it should be that he was testing more edges than us. Like, yeah, so we figured out how to bulletproof this, to use the grids and make it bulletproof. Although we had our own artifact when you zoomed in, it would pixelate a little bit if you zoomed really far in. You'd have to zoom in, yeah, probably about this big. It would start to lose precision, but not cause artifacts just not be as smooth. But yeah, it wasn't good enough. Anyway, so I need to write that article just because we did do this work and figure out some stuff, and I should share it. What else were we talking about? Oh, we were talking about DLSS, yeah. Oh, and languages, yeah, ML. Yeah, ML, the language as in OCaml. All right, I was making comments. Got to place for the 2x2 lots within the block. And that's what this code is doing. Word corner, compute word edge. Okay, this is what the actual complicated function. All right, so I don't want dark mode. Like, it's fine to prefer dark mode, but this whole culture of people thinking that quote unquote light mode is not viable, is bad, is insane. Um, like, read a book. If you can't read a book, like, you have a serious problem. If you can read a book and you can't read a screen in light mode, turn down the brightness on your screen. Like, there's something wrong with your eyes if a white screen is too bright for your eyes. Either your eyes are bad or your screen is too bright. If your room is poorly lit, then turn down the brightness on your monitor. Anyway, not for me. Like I said, it's fine for you people to prefer whatever mode they prefer, but like, stop complaining to other people who don't use that mode. That's just weird. It's a you problem. It's not a me problem. And it's a clear, like, cultural thing that's happened post, I guess, mobile phones, smartphones, probably, which effectively makes it a generational thing, largely, it seems like. And we don't need a generational war over monitor colors. I'm only guessing that it's because smartphones are dark mode, but it seems probable. Yeah, fair enough. If you're not young, I apologize for stereotyping. Yeah, it's interesting that, because yeah, I did start with terminals. I started with physical terminals, not term in X Windows or whatever, but physical terminals that were black screens. Uh, but but even then, once we went to Windows. I mean, I guess DOS was that way too, right? DOS is a black screen. But then, like, just even like the earliest, well, let's see, Turbo Pascal was black screen, but pretty quickly you got the Borland IDEs that were colored. So Turbo Pascal 3, maybe? So yeah, the blue. Oh yeah. That was the editor, the editor in DOS, whatever the default editor was. That was the blue screen. Yeah. Um, Wonder why these are black and these are blue. Yeah, um, I started on a black screen, but yeah, almost immediately I was running BASIC on an Atari 8-bit, and the Atari 8-bit and the Commodore both had the blue screens. Yeah, I started on a terminal with green. I can't remember if it was green or amber. And I've mentioned this before though. We had three, four. It was either 2 and 1 or 3 and 2 CRTs, and then we had a bunch of printing terminals, and the printing terminals were black on white because they were printers, printing with the that uh, roll the not, it wasn't actually shipped as rolls, it was pages, but the with the holes on the sides. I can't remember what that's called. Glow of a bright CRT is not as jarring as a bright LCD, maybe? Yeah, maybe. Yeah, literal paper. Uh, Let me see if I can find this on Google. Printing terminal. This isn't the one that we had, but here's an example of one. Um, yeah, and this form factor is so you could have a box of paper underneath it feeding into it. So yeah, but my high school 1980 had an old computer, and so kind of hand me down ish terminals. And so we had a bunch of printing terminals and a few CRTs. And you much preferred the CRTs because the printing terminals were incredibly slow. And they printed everything. Like you just had like you're editing a program and it's line by line printing everything you're doing. Um, does this have a this is pretty similar to what we had. Two models. We had an old model that there were like two of that was terrible, and it was something like this with the crazy buttons. And then we had a newer, slicker one. Slicker, that's not slicker. We had a bunch of the. I think the thing we had the most of was the newer slicker one. That I don't know what to look for. But anyway, um, so yeah. So in high school I started on those. So I was both amber or green on black and black on white, and then within a year we had a basic. My family bought an Atari 8-bit, and I was running basic, and then I went to DOS, like an IBM PC XT, um, the 10 megabyte hard drive. Is that right? Yeah. So we had to. So we bought the Atari 8-bit for the family, but I was the only one who used it, or I was the main person who used it. Like I turned into a full time computer hacker, quote unquote hacker, computer programmer, and then later, um, probably probably around 1990, I was using the. We had a spare PCXT that I was using. Um, and then in college, I was on. What were those? I can't remember what we had for the comp sci. So I was in the comp sci program, so we would get comp sci accounts. Like for each class, you'd get an account on a mainframe. I can't remember anything about those, how they worked. And then I think they had IBM PCs in the computer labs. Yeah, they did, because I remember playing Rogue on those. Um, and But yeah, I can't remember what the mainframe stuff was like. And then the main thing was that I knew people in the engineering department, and the engineering department had its own computer setup. So I had a permanent account on that, and that's what I used to like post to Usenet on, was from my engineering account. Um, and uh, and they had some Sun workstations. That was the primary thing I remember using. Um, that had a uh, that if you could boot. I not that I ever played with it, but I remember they programmed the equivalent of the BIOS on it, like they or something. I don't know what it was. It was programmed in Forth. I remember that. And then they started using those as X servers, as dumb clients running on some Spark machines. They had a couple Spark machines that they turned it effectively became mainframes for the engineering department that you just connected to with X with their using your the Sun workstations as dumb clients for the Spark machines. Um, I don't remember what the Spark machines were. Um, but we certainly never had like an OpenGL uh, machine or anything like that. Um, Spark was the name of the RISC CPU. Um, that was also from Sun. But yeah, we at my university we didn't have any great graphics things or mainframes. We did actually. The engineering department did get a Next. I remember seeing the Next Cube, but didn't use it. Didn't have access to it probably. Like I knew people who worked in that was how I had a permanent engineering account, even though I didn't work in the, it didn't, wasn't an engineering student. It was because I was friends with some of the guys who worked in the engineering department, some of the students who worked there. Um, and I remember them unpacking a Next box, but I don't remember using it. But so probably the Sparks were the machines that I programmed my uh, International Obfuscated C Code competition entries on, most likely. Yeah, it's funny. Like, I wonder what was the big cray, XMP? Um, 105 megahertz. Up to 4 CPUs, 200 megaflops. So then what's like a modern smartphone? The Pixel 10? That has a tensor chip in it. What's I guess what's the iPhone? 17, 16? So what's the processor? iPhone 17 ARM processor. I think I'll tell us flops. Let's take the iPhone 17. 2.074 teraflops. So if we convert teraflops to megaflops, teraflops times 1,000 is gigaflops, times 1,000 is megaflops. This was 200 megaflops times 4, so 800. So yeah, 2,500 times faster than a Cray XMP. I mean, I picked that arbitrarily. I could pick Cray YMP. Was that the last one? No, they did. Oh. Oh, that's a. The EL is like a scaled down one or something, it sounds like, from this. Since they called it a mini supercomputer. Massively parallel. Wait, Cray 2 is 1.95 gigaflops. Okay, wait. The XMP was not a good example. Or I misunderstood something. This doesn't say. Oh, here. 2.144 gigaflops. Oh, it's only. Oh, okay, yeah. Because I said 800 megaflops. Yeah, so this is only 3 times bigger. Okay, yeah, that's all reasonable. So yeah, so this one, we multiply by 800 and divide by, let's call it 2.2. So it's still 1,000 times faster than a Cray YMP. I mean, the whole thing about the Crays is that they were these vector processors, which meant they had this vector memory and could process one item in each vector. They had functional units that could process one entry in each vector every cycle. So the whole thing was that you would get this efficiency because if you had 16 items in your vector, or a lot more potentially, right? Like across 16 cycles, you would actually get 16 FMADs or whatever. I don't know if we were doing FMADs at that point. Whereas on a normal computer, you would be spending like 3 or 4 instructions to get your, because you had to load and, whatever. You had to do the stuff, so you couldn't get an operation per cycle going. But with later scalar processors, we had superscalar execution, and you have like the x86 that can do operations from memory and stuff. So you could, on the x86, say, fmad something, then store it in fmad something else, or like you're doing two things in parallel. So you're fmadding a top product. You do 2 or 4 of them in series. You can execute a few instructions and still be issuing an fmad per cycle. So it's not like the SIMD stuff. Cray wasn't doing like 4 fmads per cycle. I mean, it was because they had multiple CPUs, so each CPU was doing one. But this doesn't have any details, so we have to go back to the with 2 functional units each. So it could do two. We don't know what kind of functional units they have from this article. Yeah, here's gather scatter for the vectors. Right, so you'd be like loading up a vector in parallel, loading a vector from memory in parallel with operating on some other vector, maybe. Stuff like that. But the whole point is that it's maybe not even interesting now, but at the time I didn't understand this, was that it was only executing 1 or 2 operations per cycle. It's just that, complex flops. It was able to issue 1 or 2 flops per cycle. I mean, the peak numbers from executing 2 flops per cycle, which now, if you count an fmad as a flop, as 2 flops, that doesn't even count. Like, these were real separate flops. But it was because they did this crazy vector thing. But the vector thing was only to be able to execute 1 per cycle without the overhead of other processing. Whereas now we can do that. Now we've gone to doing SIMD vector processing, where we actually issue 4 SIMD flops on a single register. So when we were just looking at the ARM, the Apple ARM, I'm assuming the flops here are theoretical peak flops based on its SIMD, most likely, right? Rather than real world performance that you would get. Oh, wait, was that the GPU numbers? Yeah, it was the GPU numbers. Well, that's probably both GPU and... Yeah, we need to find something that doesn't include a GPU. It's an SoC with both a GPU and a CPU. I mean, I guess that's still fair in terms of comparing to the thing. It's harder to program, so it's not useful. But yeah, an actual modern GPU, like a 4090 maybe, let's say. I mean, we could go up to a 5090. Let's. Well, you can't buy it because they don't make it. But what do they say for flops? Theoretical performance. Here you go. 82.58 teraflops. What was I using as the teraflops from the A19? Oh, it's down here. Yeah. Oh, this is actually surprisingly high. So yeah, so the GPU would be another factor of 80 on top of that. So teraflops, gigaflops, megaflops, and then divide by 800 megaflops. 100,000 times faster than a Cray XMP. And then if we look at like an OpenGL workstation, so SGI workstations. So I don't know what the history of those were like. Wait, like we bought what, like 2000 era? Did this actually have graphics? Oh, they used NVIDIA Quadro cards. Yeah, okay, we want older than that. We want SGI when they were using their own graphics. So I guess IRIX. IRIX is the operating system. They're MIPS workstations and servers. So, like, can anyone tell me like what an SGI workstation before NVIDIA was? SGI O2. I remember hearing about the O2. It's an entry-level Unix workstation, so we maybe want the SGI Octane. The XBO ASIC. Oh, no, that's not graphics. That's an I/O card. So were they just doing the graphics? Okay, here we go. Here's one that actually has a thing for it. Can we find, I guess we're not going to get flops because there weren't really flops. SGI vPro flops. AI tried to answer it, but who knows? It's just a random person. How fast? It doesn't link to anything. Oh, spec numbers. Great. Yeah. No good. I mean, I guess we could look at the 251 megahertz. Do they say anything like number of pixels per cycle or anything? Double the geometry performance, but no numbers. That's fun. They just start shipping G-forces or quadros because of patents. Anyway, so yeah, they were probably not very fast. I've always been curious about what that experience of using OpenGL, or what the thing that was before OpenGL, something GL. I can't remember what it was called. Iris GL, probably, yeah. Oh, hey, look, this has the exact same text. Allowing for hardware acceleration of numerous imaging operations at real-time rates. Yeah, thanks. That's very explicit. Real-time rates at 160 by 100? Like, who knows? Anyway, all right, that was a fun little side trip. But yeah, 100,000 times faster, the 4090 versus the Cray XMP. Sort of. For a fraction of the price, especially if you convert to modern dollars, if you count for inflation. But yeah, I mean, that's the way of silicon, right? That's the whole Moore's law. Especially all the Moore's law variants, because Moore's law was the increase in transistors, but the increase in transistors is because the transistors get smaller, and the transistors getting smaller decreased power usage. So until we got the blow up from trying to crank it too fast, you just had this crazy thing. I mean, I guess that doesn't actually make it cheaper if you're running more transistors at the same size. There's no reason that should be cheaper. But presumably costs just came down as a general thing. Although they're like the craziest, expensivest thing to make, silicon chips. But maybe the chip size came down. More. Like maybe the actual, well, I don't know, the 4090 is probably a pretty huge chip. That's a lovely. What's the actual chip? Wikipedia doesn't know what the chip is, or doesn't say. How do you know what you can do in GPU compute versus CPU? Well, it just has to be, you need enough experience to kind of know. It just has to be something that you can do massively parallel. Um, I'm doing this voxel stuff is not even floating point at all, right? So like GPUs are good at doing certain types of math ops like matrix operations isn't even really relevant to what I'm doing here. On the other hand, well, and I think the GPU is good at doing this voxel thing. It's just, as I've said, probably I shouldn't be doing it on the GPU just because the GPU is idle. The AD102 graphics processor says tech power up. Here we go. A large chip with a die area of 609 millimeters squared. Now we say, what was the Cray? Well, it wasn't even a chip, probably. The Cray XMP was probably wired boards with discrete components. Or was it a big ASIC? Okay, given that size, I assume it was a big board. Yeah, so it's hard to compare. Obviously, yes, the size has gone down a lot compared to that. But let's say like what a 6502 was. Processor chip. No, not AI mode. Chip size. Millimeters. No, that's Commodore. I mean, come on, millimeters. Here we go. The original 6800 chips were blah, blah, blah. This was, is this the 6502 yet? Okay, so the 6502 back then was 19.8 millimeters squared, so much, much smaller than that. Obviously, it's not comparable. It was not a Cray XMP. But yeah, so we do have this issue that the big GPUs do use big chips. So I guess we've improved yields enough that they can use bigger chips than we used to use as part of it. And maybe the yields are bad and that's why costs are high. I don't know. The 5090. I just don't even look at the 5090 because of the absurd pricing issue. That the pricing is supposed to be, the list price is like $2,000, and now it's gotten worse because of the whole RAM thing, but the actual available price was over 3,000. What did I say that was, the AD102? yield. Well, of course they use binning to, so if you have a bad processor but it's not too bad, it's just underperforming, you can, you know, kill off a core and bin it into a smaller thing. So yeah, that does make that makes that whole analysis more complicated. Basically, they've said, hey, we can deal with bad yields. Like yield is just a continuum now instead of, it used to be a binary thing. The thing worked or didn't, and so they've if you did it that if you use that approach, then any chip that didn't hit 100% you would consider bad. But now they're like, well, this chip hits 90%, so we can just bin it into a slower processor, a slower 4080 or whatever. (20x) less BVH space. That's crazy. Well, you can't even name a real price for 4090 since it's only available used. 5090 is over 3,000. I think 5090s are up to 4,000 now, maybe. Yeah, I don't think you can find 40. I mean, wait, really? I didn't think you could find new 4090s on here at all. Is it really new and not refurbished? Claims to be. I don't know if this is legit. I'm not sure I would trust it. Yeah, I don't think I would trust that these aren't refurbished. I mean, obviously, if you get it from eBay, you can buy them used from eBay. Um, but yes, you're correct that they are pushing 4,000, 3,200, 3,500, if they're actually what they say they are. Anywho, all right. I'm about halfway through this file commenting. Maybe that's a good stopping place. I'm still sleepy. And we've been chatting for a while. I haven't really been programming, so for anyone who's wandered in, I'll show where we are. And every one of these buildings has this stairwell. All the buildings are placeholders, and their exact positioning here is placeholdery. Just trying to get it working, get the system working. This road is totally wrong. Did not respect minimum lot size. I don't know why. It's a lot of quads, given that we haven't filled in the whole city. Like once we fill in all the other buildings, it's going to be a lot more quads. So I think with this radius isn't viable on this machine. I think we'll have to pull the radius in. Then again, the fog is already pulled in pretty tight. So we probably don't have to go out that far with this fog. And while the fog seems crazy when we're up in the sky flying around, if you imagine playing this game at human scale. Where's the... What happened to the road? Oh, there's the road. If you imagine actually being at this scale, and the fog isn't so bad. Is that a reasonable running speed, or is that too fast? That seems too fast. Yeah, we'll definitely put some parts into the actual thing, but they're easy to add. It's easy to make one of these central areas not get any roads in it and just be a big park. That would cause them to only fall on those particular spots of, so we can have smaller, we could always have a single block that's just a local greenery. .980 Ti is around the performance of an RTX 3050, somebody says. That's because that's what's in this development machine. Yeah, it's a pretty heavy 250 watts TDP. We have something besides a rectangular grid. Yeah, in places, but it's a voxel engine, so it's going to be rectangular-y. But the whole point of this scheme is that we're not just superimposing a regular rectangular grid. It's going to be locally varying. And for now, I'm filling in this middle area with a regular grid or semi-regular grid, and then it's more complicated how this stuff works. But there will be places like this will connect to this, like this will do a little thing like that, which will make this, well, it actually makes this block be this weird shape, but I guess this would connect like that. But anyway, it will leave this thing here as a sort of L-shaped thing. Like you connect this to this, so on one side it's a rectangle and then the other side it's L-shaped. So it'll be those little L-shaped things. And then we'll just intentionally, in this area where we have total freedom, we can induce other shapes. And I mean, technically we have total freedom on the corners. Right now we're saying every corner is always 2 by 2, but we could just make the corners arbitrarily whatever. It's just making them simplifies what the chunks have to worry about, because they know the corners are always just sticking in a rectangular thing. Yeah, I mean, obviously the power usage is way worse for the yeah, that's interesting. If you look up, we just don't get any frustum culling or something. I guess because we're not using the actual quads, we're using the we don't know the actual dimensions. We know we use the bounds of the whole thing. So when you look up, everything could do. Like if we were on the ground and we look down, yeah. But when we look up, everything could have these tall towers that stick up. Like, let's add a post. Let's add a post to every building. Make building. No, not make building. Create building. Let us say P equals put slab. We want the center. Where's the center? Oh, yeah, that's right. The center is here. X minus 1, y minus 1. X plus 2, y plus 2. 1000. Yeah, so now we have a little post for every single building showing the limits of the map. And then if we look up, you can see the posts from neighboring chunks, which is what causes them to keep rendering. So if we flew high enough, we would stop rendering the neighboring chunks, yeah, as you can see. We don't even pass in a seed to these. So I can't actually do anything random. Oh, we do, R. So we'll leave this in as Z base plus num floors times floor height plus R mod 7 plus 2. It's not num floors, it's floor count, just floors. It's just having written the code, might as well leave it in. Yes, but the culling far voxels isn't very important because the shader, the pixel shader is not where the time is going. The vertex shader and the rasterizer is where the time is going, and so because there's just lots of tiny triangles in the distance. These were supposed to all be different heights. They don't seem to be different heights. Maybe R isn't actually a random number. I thought it was. Create building. Get rand. Okay, then why is that not varying in height? Is R getting overwritten? It's getting different values. I'm so confused. They're clearly all the exact same height. Different areas have different height, but it's like if the buildings are the same height. That's the only call to create building. It's calling get rand. Oh, because it's coming from B arrow seed, and apparently B arrow seed is not being initialized properly. What is that? That's from building. Make building. That takes it past in seed. That calls get rand. Aha. Don't know why that path is in seed. Don't even know where that seed is coming from. For some reason, we're using the same seed for all of them. Maybe there was a reason that I did that. I don't know. Where was one of those long rows of buildings? Oh, well, hey, that's why all the buildings were exactly the same size, because they were, I wasn't even thinking about them, but they were all the same height. Like they were exactly matched. And that was because they were all using the same seed. And now they're not. So now we're getting more variety. Although in some ways it looked better to have them be more consistent, so we will have to fudge that back in. I don't think we're getting the sides correctly. Yeah, which side is supposed to be red is not being updated correctly here. All right, but we're done. Any last questions before we end the stream? I will check in. Give you 10 seconds to finish typing a question if you're in the middle of one. I do not know when the next stream is. I mean, last week I only streamed once. Didn't predict that. Just, that's what happened. Can't tell you. I always pre-stream so that you get the Twitch notify comes in. It is potentially going to get sent 15 minutes before the stream, typically. So if that takes a little while to get to you, you hopefully have time to react. All right, that's it. See y'all next time.